In this video we're going to talk about the evaluation section, and that contains various parts, the first of which is the conclusion with respect to the research question. So in the hypothesis section and in the research question we made a number of predictions, and now we're going to see if those are true. We're going to calculate any numbers that we said we were going to calculate. So the last time we worked out the intercept with its uncertainty, and we worked out the gradient with its uncertainty. So the fact that we predicted the intercept would be 0, and that's what we found, is relating back to the research question, so that's good. Then we also predicted that it would be a directly proportional relationship, which is what we found by the fact that it was linear and that the line of best fit contained the origin within the error bar. We can now compute the spring constant, which is the thing that we said we were going to do, by using the gradient, which is here. Those are the numbers from the background section, the numbers of the constants. So once we've got the spring constant there, 48.1 newtons per meter, what we need is the uncertainty on that, and the reason we need the uncertainty on that is for the next part. So we calculated the number we said we were going to compute, and we linked these back to the research question. So that's the first part. Now what we have to do is compare this to accepted scientific context, which is to say, we have a number which we've calculated, and now we need to be able to compare that to the true value. So, we can work out what the percentage uncertainty is. And for that we need the percentage uncertainties in the various components in the thing. So, the percentage uncertainty in K would be 2 lots of the percentage uncertainty in D, plus the percentage uncertainty in the gradient, plus 2 lots of the percentage uncertainty in X, the extension. So we calculate all those things. You add them all up, that's plus or minus 9%, which is 48 newtons per meter plus or minus 4 newtons per meter. Noting that what we've done here is we have matched the decimal places on the value to the decimal places on the uncertainty. So we've calculated the thing that we said we were going to calculate. Now we need to figure out if that means the experiment is accurate or not. So, first of all, 9% precision, pardon. Now, I've initially said it was reasonably precise. Now, that's not scientific at all. I would say somewhere between, well, let's say 5% is precise for a high school physics lab. This is a pretty good baseline. Anything more than that, and what we need to do is we need to start discussing how to bring this percentage uncertainty down. So when we're talking about percentage uncertainties and precision, what we're trying to do is compare it to, let's say, 5%. Anything less than 5%, that is a precise value, and anything more than 5%, that is imprecise, or insufficiently precise. Right then. So we are not bad precision, but it's not as precise as it could be, and we're going to discuss how that will be now. And now we need to discuss the accuracy. So the accuracy is how close the thing that we said was to the true value. So if we were to plot this is the value that we computed with its error bar, and if the true value is within this error bar somewhere, doesn't matter where, we say this experiment is accurate. And if the true value is outside of the error bar, we say the experiment is inaccurate. So I did something maybe I shouldn't have done here by calling it Concannon Industries. I needed a number to compare it to, and so I made up a number. Now that's not what you have to do in the real one. What you have to do is you have to find a number from somewhere and quote it. So, for instance, if you were measuring g, the acceleration due to gravity, then what you might do is you might quote this from your data book, and then you would have a reference. So you need a true value from somewhere with its reference. So The true value in this case, 50 newtons per meter. What we said is it was 48 plus or minus 4 newtons per meter. The manufacturer's error value is contained by my error bar, so the experiment is accurate. We talked about accuracy and precision. So that is these first two parts. We've concluded and we've compared to the accepted scientific context.